Next, we are going to see another important rule, which is the sine rule. Suppose we have a triangle. Let us suppose we have this triangle. This is A, this is B, and this is C. And the magnitude of BC is A, the length of the side AC is B, small b, and this is C. Suppose ABC also represent the angles of this triangle along with their representation as vertices of this triangle. Then the sine rule states that A upon sine A is equal to small b upon sine B, which is also equal to C upon sine C. This equation represents the sine rule. Now we are going to see how can we apply this sine rule that in the concept of parallelogram law of addition, so that this will help us in finding a lot of solutions easily. Let us suppose we have given this as A vector and this as B vector. Now let's draw the diagonal of this reconstructed parallelogram, which will represent the resultant of these two vectors, A vector and B vector. Now the angle between A vector and B vector is theta. That means this angle is theta, and the angle that the resultant R vector is making with A vector is alpha. And let us suppose this angle is beta. Now we know this angle is also going to be theta. Corresponding angle concept, because these two lines are parallel. Now let us see this triangle. In this triangle, this angle is pi minus theta. Because this is theta, by linear pair we can say that this angle is going to be 180 minus theta. By applying sine rule to this triangle, we can see, let's name it as A, B and C. By applying sine rule to this triangle A, B and C, we are going to get R upon, R represents the magnitude of this vector R vector, R upon sine of this angle, which is sine of 180 minus theta, which is basically sine theta, which is equal to A, this is not A, yeah, this is A upon sine of beta, which is also equal to this length, which is B upon sine of alpha. In this way, we can apply sine rule to vectors concept. This concept may be helpful in solving equation directly without much problem. Now, in this question, we are given that mod of R vector is 6, mod of A vector is 4. This angle is alpha, that is the angle which the resultant makes with A vector, and the angle between the two vectors A vector and B vector is 60 degree, that is theta, and this is B vector. We are required to find alpha, beta and the magnitude of B vector. So let's start solving. We can solve this problem easily using the law of sines. It is the sine rule which we have studied just. Using the law of sines, we can write R upon sine theta is equal to A upon sine beta is equal to B upon sine alpha. Now putting the values, The magnitude of r vector is 6. Theta is 60 degrees. So sine 60 is basically root 3 upon 2. The magnitude of a vector is 4. We are getting sine beta equal to b upon sine alpha. Now, from this expression, we are going to get the value of beta. We can further simplify 6 to 12 upon 4 root 3 is equal to 1 upon sine beta. Here we can cut 4, 3, 12, root 3, and we are going to get root 3. So, sine beta is equal to 1 upon root under 3. Root 3 is basically 1.732. So, this value is going to be less than 1 and greater than 0. So, it satisfies the range of sine. So, the value of beta exists, and the value of beta is sine inverse 1 upon root 3. So, we can write beta is equal to sine inverse 1 upon root 3. Now, from this expression, the second line, we are going to get the value of b if we find the value of alpha. Now, we know that by exterior angle property, this angle is beta. So, alpha plus beta is equal to theta. So, we can write alpha plus beta is equal to theta. So, therefore, alpha is equal to, theta is basically 60 degree, which we can write it as 5 upon 3 minus beta, which is basically sine inverse 1 upon root 3. So we have also got the value of alpha and also beta. Now it will be easier to find the value of b from this expression. I hope all of you can do that. Next, we are going to learn the meaning of subtraction of two vectors. That means, suppose we are given a vector minus b vector. A vector minus b vector. The meaning of this is basically adding a vector to minus of b vector. So saying that a vector minus b vector is equivalent to saying a vector added with minus b vector. It means, suppose this is a vector and this is b vector. Now, by parallelogram law, this will be the resultant R1 vector, which is a vector plus b vector. Now, we have to find the resultant of a vector and minus b vector. So, this vector will be minus b vector, and the resultant of a vector and minus b vector is basically this vector, R2 vector. So, this can also be written as R2 vector from this diagram. Next, we can see if we are required to find the resultant of a vector and minus b vector, how can we proceed? Suppose this is a vector and this is b vector, and the angle between them is theta. Then, if we are asked to find the resultant between a vector and minus b vector, that means we are required to find R2 vector. The magnitude of R2 vector, we are required the direct formula of finding the magnitude of R2 vector in this diagram. Then, from this figure we can see the angle between a vector and minus b vector is basically pi minus theta. So, by putting the value of the angle between the two vectors, a vector and minus b vector, that is pi minus theta, in the direct formula that we have already found, we will get the resultant, that is R2 vector. The magnitude of R2 vector. The initial formula was R is equal to root under a square plus b square plus 2ab cos of the angle between the two vectors. Now we are required to find a resultant. Our resultant is the summation of a vector and minus b vector, which is also equal to a vector minus b vector. Now, in order to find the direct formula of r, we should know the angle between these two vectors, this vector and this vector, which is pi minus theta. If theta is the angle between a vector and b vector, then pi minus theta is going to be the angle between a vector and minus b vector. So, putting the value of angle into this formula, we are getting r is equal to root under. The magnitude of a vector is basically a. The magnitude of minus b vector is also going to be b. So b square plus 2ab, because a represents the magnitude of a vector, b represents the magnitude of minus b vector, cos of the angle between these two vectors, that is pi minus theta. Now, we know that cos of 180 minus theta is minus cos theta. So, we are getting another formula, root under a square plus b square minus 2ab cos of theta, where theta is the angle between a vector and b vector. Angle between a vector and b vector. Let's do an example. Here we are given that the magnitude of a vector is 4, the magnitude of b vector is 7, and the angle between a vector and b vector is 60 degree, which is theta. Now we are required to find the resultant of the magnitude of the resultant of a vector and b vector, and the magnitude of resultant of a vector and minus b vector. This can also be written as a vector plus minus b vector. So R2 represents the magnitude of the resultant of a vector and minus b vector. Here we have to calculate this also. So using the direct formula for R1, we will get the magnitude of a vector square, which is 4 square, the magnitude of b vector square, which is 7 square, 2 times 4 multiplied with 7 times cos of the angle between a vector and b vector, which is 60 degree. This can be simplified. I hope you all can do this. And R2 is root under the magnitude of a vector square, which is 4 square, the magnitude of minus b vector square, which is 7 square, 2 times 4, 7, and cos of the angle between the two vectors, which is a vector and minus b vector. If the angle between a vector and b vector is 60 degree, then the angle between a vector and minus b vector is going to be 180 minus 60, which is 120 degree. In this way, we can solve this problem easily. Now, we are going to solve another problem, diagrammatic problem. Suppose we are given this as a vector and this as b vector. Now, we are required to draw a vector plus b vector, a vector minus b vector, b vector minus a vector, minus a vector minus b vector. We are required to draw these 4 vectors. Now we know simply that if we complete this parallelogram, this is going to be a vector plus b vector. Now a vector minus b vector is basically a vector plus minus b vector. That means the resultant of a vector and minus b vector. So in order to find the resultant of a vector and minus b vector, we have to draw minus b vector, which is going to be this vector. This vector is minus b vector. Now we have to find the resultant of a vector and minus b vector. So this, if we complete this parallelogram, we will get the resultant of a vector and minus b vector. So this is going to be the resultant, A vector plus minus B vector, which is simply A vector minus B vector. Now, if we are to find a resultant of B vector minus plus minus A vector, that means the resultant of B vector and minus A vector, we have to draw minus A vector, which is this vector. Now, the resultant of B vector and minus A vector, B vector and minus A vector is going to lie in this parallelogram. So this vector is B vector minus A vector, or B vector plus minus A vector. Now, to find the resultant of minus A vector plus minus B vector, this can be written as minus A vector plus minus B vector. We are required to find minus A vector, this is minus A vector, minus B vector, minus B vector. So the resultant will be obtained as the diagonal of this parallelogram. This resultant vector is the resultant of minus A vector and minus B vector. We can write it as minus A vector minus B vector. This exercise is an important one. Next, we are going to see some important set of formulas. Number one is the magnitude of A vector is always equal to the magnitude of minus A vector, as we have already seen. The next one is the magnitude of A vector minus B vector is simply, we can take negative sign out from this term, minus of B vector minus A vector, and this is simply my magnitude of B vector minus A vector. So magnitude of A vector and B vector is simply magnitude of B vector and minus A vector. So magnitude of A vector minus B vector is simply magnitude of B vector minus A vector. Next, we are going to do another important example. In this example, we are given two vectors which are of equal magnitudes. It means, suppose we are given two vectors of equal magnitude A, the magnitude is A, are inclined to each other at angle theta. That means the angle between the two vectors is theta. Let us draw the diagram. This is the magnitude of this vector is A, the magnitude of this vector is also A, and this is theta. Now we are required to find the resultant vector, the magnitude of the resultant vector along with the angle alpha made by the resultant vector on this vector. So we are required to find alpha and the magnitude of the resultant vector r. Now using direct formula, we can write r is equal to root under a square plus 2 times a multiplied with a cos of angle between the two vectors, which is theta. So we are getting it as a square 2a square plus 2a square cos theta. So we can take 2a square common, 1 plus cos theta. Now we should note one important formula, which is 1 plus cos theta is equal to 2 cos square theta by 2. And the next formula is 1 minus cos theta is 2 sine square theta upon 2. This is an important formula, and this formula is also important. So here we can write 2a square, 1 plus cos theta is 2 cos square theta on 2 So we are getting it as 2a cos theta by 2. So the value of r is 2a cos theta by 2. Now let me rub the board. Now we know the direct formula as tan alpha is equal to b sin theta upon a plus b cos theta, which is a sin theta upon a plus a cos theta. Now we can cut a and now we can write sin theta as 2 sin theta by 2 cos theta by 2, because sin 2 theta is 2 sin theta cos theta, and 1 plus cos theta is, as we have already seen, 2 cos squared theta upon 2. So 2 gets cancelled and 1 cos theta by 2 gets cancelled with 1 cos theta by 2. So here we are getting tan theta by 2. Therefore alpha is equal to theta by 2. And the value of r is 2a cos theta by 2. Let us say its physical meaning. Suppose this is one vector. It is suppose a vector and its magnitude be a, and this vector be b vector whose magnitude is also a, and the angle between them is theta. Then the magnitude of this resultant vector r is 2a cos theta by 2. This is one formula, and this angle alpha is theta upon 2. That means the resultant vector r vector is going to pass through the midline of these two vectors. Next, we are going to see resolution of vectors. Any vector in the plane of two vectors, two non-zero non-collinear vectors, a vector and b vector, can be expressed as the linear combination of a vector and b vector. That is, suppose this is a vector and this is b vector. Now any vector, suppose we take c vector, which is lying in the plane of a vector and b vector, this 2D plane, that is the plane of this board, can be written as the linear combination of a vector and b vector as, let us take c vector is equal to lambda times a vector multiplied with mu times b vector, where lambda and mu are some scalar quantities. It means scalar numbers. In this way, we can resolve a vector into its component vectors. Next, we are going to see projection of vectors. Let us draw the xy plane. Suppose this is x-axis and this is y-axis. Now, let the unit vector in the direction of x-axis be represented by I cap. I cap is the unit vector along the x-axis and j cap is the unit vector along the y-axis. Let this vector be a vector. Now, we are going to see its projection on the x-axis. Now, if we draw perpendicular from this point upon this line and from this point upon this line, then this vector is, let us suppose, a1, and its magnitude be a1 and its direction is I cap, and this vector is a2 j cap, this portion. Then a1 is called the x component of this a vector and a2 is called the y component of this a vector, or a1 I cap is basically the projection vector of a vector in the direction of x-axis, and a2j cap is the projection vector of a vector in the direction y-axis. Therefore, we can write a vector is equal to a1 I cap plus a2 j cap. Let's draw that diagram once more. This vector is suppose a1 I cap. The magnitude is a1 and the direction is represented by I cap, and this vector be a2 j cap. Then the parallelogram law, this is the resultant vector a vector, so we can write the resultant of a1 I cap and a2 j cap is a vector. So therefore we have written this statement, that is a vector is equal to a1 I cap and plus a2 j cap. Now suppose we are given a vector is equal to a1 I cap plus a2 j cap. A vector is equal to a1 I cap plus a2 j cap. Then we can write number 1, magnitude of a vector as root under a1 square plus a2 square. We can see this justification from this diagram. This is a1 I cap and this is a2 j cap, and this was a vector. So the magnitude of a vector is given by the Pythagoras theorem, that is a1 square plus a2 square is going to be a square. So from here we can derive this expression, and the unit vector along a vector, that is a cap, can be given as we have already discussed as a vector upon magnitude of a vector, which can be written as a vector is a1 I cap plus a2 j cap divided by magnitude of a vector, which is root under a1 square plus a2 square. So we can write it as a1 upon root under a1 square plus a2 square multiplied by I cap plus a2 upon root under a1 square plus a2 square j cap.